students, today I am going to explain you about language translators, programming language translator. In my first video, I have already told you about programming language, types of programming language and some of the characteristics of C. So now about language translator. Translator itself is telling that it is translating. Okay. So translator in programming language means to translate. Now what to translate? So first of all, we must understand this, that regardless of any language we are using, we have to convert our program into a language that computer understands. Okay, that computer will understand. So that is a role of translator. That is a role of language translator here. So basically there are three types of translator we use. First is compiler. I have discussed in first video also. Second is interpreter. And third one is assembler. So I'll explain in detail about compiler and interpreter. A compiler is a program that converts program written in source code into machine code. Okay, or you can say source code into target language or binary language. So compiler converts high level language into machine code. Now just see, it's our source code and source compiler converts it into object code. You can say machine code also. So here in compiler, we are not getting the output now. Okay, we are just converting source code, the program which we have written in English like language, into object code or machine code in the form of zeros and ones. So source code is getting converted into object code, or you can say machine code, or in the form of zeros and ones, or you can say high level language into machine level language. So in compiler, we are converting source code to object code, but till now we are not getting the output. Okay, how we are getting the output? When this object code with linker and loader gets connected with linker and loader, then we are going to get a executable file. Means after this object code with linker gets executable file. After getting executable file, we can run this executable file on different inputs to get output. So here this is the process in compiler. Source code, compiler converts into object code. After that, this object code with the help of linker, when the object code is get connected with the files in linker, gives the executable file, and then after giving different inputs to the executable file, we can get the output. So this is compiler. In source code, we write with .c. In object code, extension is .obj. In executable file, the extension is .ex. Once we got object code, so during compilation, there is no need of source code and compiler. Once object code is with us or machine code is with us, so there is no need of source code and compiler. With the help of object code, we can get executable file and we can get the output. So this is the working of compiler in actual. So when we compile a program, usually you do in the labs, compile a program. So it gets successfully compiled when there is no error. If there is error, compiler will tell the error. If there is error, it will tell the error in the number line. You have to rectify that. Then only we can get the object code. Okay. Now about interpreter. So interpreter is also a program that converts or that executes the instructions written in high level language. Or you can say it converts the source program and executes at the same time. So with the help of diagram, if I'll explain, so you can say source code. Here we are having interpreter, and here we get the output. So no object code is there in interpreter. We have source code, it converts and executes at the same time, and we get the output directly here. But instead in compiler we get object code. After linking with the linker, we get the output.
Now we will discuss about the difference between compiler and interpreter. I already told you what is a compiler, basic working of a compiler and interpreter. So before going to the difference, I want to tell you both compiler and interpreter are programs that convert program written in source code, that is in high level language, into machine code, or you can say object code that computer understands. It converts high level language to the language that computer understands. Now taking different parameters. So first parameter we are taking as input. Input, when we talk about input, a compiler takes a program as a whole. Its input is a program as a whole, whereas interpreter takes single line of code, line by line it takes. Now the second parameter is output. So the compiler generates intermediate machine code. So compiler, I already told you the explanation also, compiler doesn't give output. The output is given when the code given by compiler, that is machine code or object code, is linked with linker, then we get the output. But here in compiler the compiler generates intermediate machine code, okay, whereas in interpreter output is given, okay, no intermediate machine code is there, okay. Whereas when we talk about errors, the translator displays, this translator, compiler translator displays all the errors compiling together at the same time. At the end, when we compile, at the end it gives all the errors referring to the line number. Whereas interpreter displays the error of every single line one by one. So when in the case of interpreter, first line is executed, and if there is some error, first of all, before going to the next line, we have to rectify the errors of first line, then only we can go to next line. In the case of interpreter, whereas it gives error as a whole program is executed, after that it gives error. In this case, single line, then error, we will rectify, then we can go to next line. While talking about runtime, so compiler programs run faster as compared to interpreted programs. The interpreter is slower as compared to compiler. So while talking about compiled programming language, C, C++, C#, all these are compiled programming language, whereas Perl, Ruby, PHP use interpreter. These are the programming languages which use interpreter: Perl, Ruby, PHP. These are the examples of programming language: C, C++, C#, which use compiler. Now about object code. Compiler generates object code which further requires linking, hence require more memory. In compiler, the memory requirement is more as compared to interpreter. I will tell why. So in compiler, when we get object code, once we get object code, or you can say machine code, source code and compiler is of no use. We don't require them once we get object code, because now with the help of object code and linker, we will get the output, okay. Whereas in interpreter, no object code is generated, because in interpreter the execution and interpretation takes at the same time, hence no extra requirement of memory is required in this interpreter.